All right, so today I'll try to give you some hints or some information about what wideband is, what wideband thinks we can do with Asterisk, and more oriented to conferencing precisely. So first I'll try to explain what wideband voice is, because sometimes we talk about wideband, but the concept itself or what it's based on, it's not that clear. Then, well, I'll also answer the question, should I use wideband anyway? Because, well, you might be comfortable enough with G711 or any other narrowband codec, and you might not even want to, but we'll see if you do, really. Then I'll explore Asterisk's wideband capabilities. So as John said, recently more codecs were added. G722 has been there for a while, and we'll see what we got there and what we can do about it. Then we can also make conference calls with Asterisk. This has been around for, seems like, forever. And, well, we'll see what options we have, which is the main purpose of this talk, like explore which options we have to make audio conferencing in wideband with Asterisk, both built-in modules and third-party applications. And then I'll provide, well, my testing, let's say, environment and what this environment showed me, like what I learned from doing these tests, and then what was my choice after doing all this. So to me, wideband voice is just having a higher quality voice which is more detailed. So I know who is talking. I don't need to look at the caller ID to know that somebody is talking, because it can identify his voice. It has a richer sound. So actually, this is nothing new. G722 is from 1988, since ISDN stuff. So in the end, this is nothing new. We are just bringing it on right now. So how does this wideband work? Well, human voice ranges from 30 to 18 hertz. And as you can see in the curve over here, the most part of the voice energy, which is what defines our voice, it's comprehended between more or less 0 and 4 kilohertz, which is what, for example, ALO uses. So if you transmit all this information, you pretty much have all the voice data there. But if you want more or richer data, you want to better define the voice so that you can identify who is talking better, you want wideband, you need to transmit more stuff. So that's what you actually do with voice. You need to transmit more frequencies so that you get richer sound in the end. And how does this work? Well, to get a little bit theoretical here, I'm not an expert either, but let's see. So the Nyquist sampling theorem states that if you want to transmit, for example, 4 kilohertz of frequencies, you need to sample them at double the frequency. That is, you need to sample them at 8 kilohertz. So, for example, ALO transmits 4 kilohertz up to 4 kilohertz voice. So it's the sample rate, it's 8 kilohertz. This is it. So G711, we transmit this range of frequencies, and we use this sample rate. So this is important because in terms of hardware computing or software as well, we need to take care of this because, well, if we want wideband, we need to sample it like at a higher rate. For example, in G722, we want to transmit more data. We want to transmit up to 7 kilohertz of voice frequencies. So we need to sample it at 16 kilohertz effectively. So that's a requirement we have. This is, well, how wideband voice. We have even more wideband codecs which need higher sample rates, but I just based on G722 because it's somewhat the most used one or the standardized one that everyone uses right now. Then one good thing about G722 is that it uses the same bandwidth, meaning network-wise, for transferring this data. So it's 64 kilobits per second. So how come we have this if one is wideband and the other codec is narrowband? So G711 uses PCMA for coding data. So it uses 8 bits per sample multiplied by 8,000 samples. You need 64 kilobits just for the audio part. Whereas G722 uses subband adaptive differential PCM. So it's different. It means that it uses 2 bands. It uses one band for the lower part of that curve we showed in the previous graph, which is for the first 4 kilohertz, and then it uses another band for the upper 3 kilohertz remaining. So it needs, you actually need to sample it, like you need more information in the lower part because it contains more data from the voice. So that's why it uses 48 kilobits per second for the lower part and just 16 kilobits per second for the higher part. So just by mixing these two together, you get higher quality with the same bandwidth usage. So this is more or less what I wanted to show you. Like this is what you're sampling with ALO, with G711 or ULO, and this is what you're sampling with G722. But you use the same bandwidth in the end. So then, should we use wideband anyway? Well, for sure, to me, yes. And of course, you do want to use wideband. Why would you use it? Well, you have cleaner sound. You want to understand people better. When I try to communicate with my boss, with my colleagues, I don't want to talk about how horrible you sound or not. I want to talk about what we do. So I want to hear just good, just perfect. And actually, for example, there are quite some words like sailing or failing, which have sounds that look much alike. So with narrowband codecs, this is an issue, whereas with wideband, you can hear clearer what he's saying, and you don't have to stay all the time like, what? And just get that repeated again, because it's very annoying. So just to give you some more data on how the usage has grown on our public service, sip2sip.info, now 25% of the calls are being performed, well, are being done with using wideband codecs, whereas same period last year, it was only 2%. So looks like over 1 year, we got a very high growth of wideband usage that we could observe. So we can extrapolate this to like the world and believe that it's being actively used and more. Now, about Asterisk, which is what all this is about. We have narrowband codecs. We have a bunch of them, like, I don't know, G711, GSM, 729, ILBC. And in the wideband part, we have G722 as first, as I said, the most used one. Then we have the Polycom's Siren codecs, G722.1. And since Asterisk 1.8, we got two very nice additions, which are SPICs, wideband SPICs. We already had SPICs, but 8 kilohertz SPICs. This is 16 kilohertz SPICs, the wideband version. And we also have G719 pass-through, which is also new in 1.8. So there are more codecs that, like Skype's Silk codec, which it's not there yet. But, well, I'm not aware of any hardware or software SIP client doing Silk. So in the end, I guess at some point we'll get there, but we'll see how the market goes. So about conferencing, there is not much to say about what it is. You already know. But let's see. We can do conferencing several ways. We can do conferencing client-side. So you can have a fancy client that mixes all the audio together, like Blink does, for example. And you have, well, you can do it this way. So you start all the calls and you mix the audio yourself. But if you want to jump out of the conference, you can't without just destroying it. And you also need the whole bandwidth to actually send audio to all the participants. So this is one way to do it. It depends on the number of participants you want to do it. If it's a small conference, it will be very nice to do. If it's big, you can still do it. I mean, the CPU usage is not high. It means you can mix it. But if you are doing it across the internet, you might need a big line for that. Well, if you can do it server-side. If you already have an Asterisk PBX, you just might add the conferencing abilities. You have the applications. You can just build it there. You have the tools. So you just add it. And you might not care of that, and you might just outsource it. There are nice hosted services for this, which you just dial a URI or you can schedule a conference. So it's not done on your premises. You don't care about it. And, well, it's yet a different way of doing it. So there are several ways of doing conferencing, and wideband, of course. And I'll explore the server-side conferencing with regards on Asterisk. So Asterisk has several applications for doing channel-independent conferencing. So this is important because one good thing about Asterisk is that we can mix a call coming from a SIP client, a call coming from an analog line, and a call coming from a GTalk into the same conference bridge, which is something you cannot do with everything else out there. So the first application that has been around since forever, it's MeetMe. The mixing, it's done at DADI level, and we all know it because it's been there always. But it doesn't do wideband. Why? Because the mixing, as I said, it's done at DADI level, and DADI is the support for analog and digital lines, and it samples at 8 kilohertz, period. You cannot go beyond that. So MeetMe, it's not the choice you want to make if you want wideband conferencing. Then we have ConfBridge, which is quite new. It's been around since Asterisk 1.6.2. It uses the new bridging API, which was done, if I recall correctly, by Joshua Kolb. And no DADI is needed, not for timing nor for mixing. So it's completely independent. It's wideband capable. It can do mixing at 16 kilohertz or 8 kilohertz, but not both at the same time. So this is currently a limitation. But if you can live with that, then you're fine. It doesn't have as many options, as MeetMe does, but that's yet. Somebody might add them in the future. And then last application I went through, it's APP Conference with K, which is a third-party application forked from another one called APP Conference with C. It's been around since Asterisk 1.0 because at that time you needed Zaptel for timing. So in Asterisk you need to provide timing in order to sample the packets correctly. So they wanted to remove this limitation. So that's why they made this. But it's not in the mainstream. It's wideband capable, and it's video capable as well. It has a VID for video, so it will switch the speakers to the speaker's video source if he's speaking, of course. But it doesn't work with 1.8 yet. And, well, for this talk, I wanted to check the bleeding edge stuff. So I'll just make a note on timing because some people feel confused about why you need DADI sometimes. Like you need DADI for MeetMe and you need DADI for timing, but that's not the same thing. MeetMe always needs DADI because it mixes with DADI. But then you have the timing interfaces to sample the packets. So the full explanation, you can find it there on the documentation on the Asterisk source code. So it supports several timing interfaces which you can use to provide timing. They are ordered from higher accuracy or the better to the worst. So the timer FD interface is the best one. It runs only on Linux and with a certain version of kernel and glibc. It's a very reliable source of timing. Then we got the KQ, which is the best timing interface you can get on a VSD-like system. And yes, Mac, it's VSD in this case. It has KQ. You can run ConfBridge on your Mac. Then it comes DADI. So as you can see, DADI, it's not like the ultimate source for timing. It's just one of them, and it's not even the preferred one. It just uses the card's built-in hardware to provide this timing. And the last one is the pthreads timing. So any system supporting POSIX threads can provide timing. It's like the worst timing source you can get, yet it might be good enough depending on what your needs are. And now back to the applications. This is what starting a call in ConfBridge would look like. So there is no configuration file. It has some, well, as I said, it uses the new bridging API, and it bridges quite smartly. So if there are only 2 participants in the conference, it's effectively the same bridge type. It's the same thing as doing a dial in your dial plan. So it doesn't make any fancy difference between them. But if you start to add channels to this conference, then it will morph into something else which is able to do the mixing. Just a hint, be careful. You can, as I said before, you cannot mix different sample rates so you cannot talk ULO and ALO and G722 at the same time without being downsampled to 8 kilohertz, or maybe you just don't hear anything at all. And one bad thing about this is that currently there is no way you can force the inbound codec. So from the dial,